And I realized I forgot to record the lecture for today, so I just started doing that. Hopefully that works out because we're about to start the new material, so I think it should make sense for everyone. Okay, I'm gonna give like 5 more seconds for this first part. Cool. So here's what we're going to be looking at today, which is tangent line / linear approximation. So it's like tangent line / linear, and then the approximation is by itself. A lot of times I feel like if you look online and you want to Google stuff about it, it's just going to be called linear approximation, if you care about that. But I would like everyone to write down the key idea, which is that we can approximate the value of a function at a nearby point by plugging it into a tangent line equation. So I'm going to give everyone like 20 seconds or so, a bit more maybe, just to copy that key idea down. And then I'm going to illustrate that really quick.
Hey, can you repeat? Sorry. What do we have to write down?
The key idea. Is my audio an issue at all, or is it just?
Oh, no, I hear you. I just thought you had to yeah, I didn't see on the paper.
Okay, yeah, the key idea here. And then just try to, as you're writing it down, just try to think about what that means. Okay, I'll give like 10 more seconds or so. Okay, so I'm gonna try to draw this out. You don't have to draw this again because I'm just kind of freehanding this. But the idea is that, let's say I have a function, right, on this graph, and this function, that's not good, but let's say it looks like this or something like that, right? And we find the tangent line at point A, right? So I draw this tangent line. Let's say it looks like this. Not perfect, but you get the idea. Yeah. The idea is basically that we can use this tangent line, although let's say this function like is a really weird function, and then we found the tangent line at point A, but like we're trying to find point B, right? We're trying to find the value of point B on this function, but we can't plug it in. So for some reason we can't plug it in. This function is like f of x is like some super weird function. I don't know when that would actually happen, but that's besides the point. So we can't find point B, but we can use this tangent line because it's tangent to the slope, and we can approximate point B by finding the equation of the tangent line, and then finding the corresponding, like using the corresponding x value for point B to find like this, like I'll call this approximation of B. And this approximation of B is going to lie on the tangent line. So that's literally the entirety of tangent line approximation. I think it's actually, I feel like a lot of you guys could probably figure out how to do one of these problems without even me explaining any further, because you know the x value of B, right? You know the x value of B, and then you know how to find the equation of the tangent line. So I think the next steps are pretty intuitive, but we're going to go through an example right now. So I'm going to do this really quickly because we kind of already did this process in the do now. Our first step is just going to be find equation of tangent line, right? So first, Samantha took us through this whole process, but first we find the slope, right? So we have f of x is equal to x cubed minus 3, so f prime of x is equal to 3x squared, right? So f, the tangent line at x equals 2 is we just plug in 2. Prime of 2 is equal to 3 times 2 squared. That's equal to 3 times 4 is equal to 12. So we know m is equal to 12. So I'll give people to catch up on this, give people a couple seconds to catch up. And then f prime of x I found simply through power rule, right? Like x cubed, bring the 3 down, subtract 1 from the exponent, so you get 3x squared. I'm sorry, I'll give people time to copy down the question too, because I don't think I gave people time to copy that.
I have a question.
Yeah, go ahead.
In the equation, wait, never mind. I'm sorry.
Oh, okay. Let me know if you have a question. You can chat me if you have anything you want to clarify. Okay, so now I'm going to move on to, we found a slope, right? And we know through point slope form, what's the other thing we need? We need a point. Oh, shoot. Give me 1 second. I'm going to plug in my laptop really quick. Okay, so we need a point, right? And we're already given basically that the line is tangent to x equals 2. So we have x equals 2 as a point. So how do we find y? Well, we just plug in y. So, well, we plug in x. So f of x equals x cubed minus 1. Let's plug in 2 for x. So f of 2 is equal to 2 cubed minus 1 is equal to 8 minus 1 is equal to 7. So our point is going to be 2, 7. So cool. We have our slope, we have our point. Now let's just find the point slope. Let's find our equation. And our equation, we follow y minus y1 is equal to m times x minus x1, right, for our point slope form. Cool, so we have our y1, right? This is y1 comma x1 comma y1, so it's y minus 7 is equal to m is 12, so 12 times x minus x1, which is 2. So cool, that's our first part, and that is a big part of the battle for linear approximation. We found our equation. So basically, if you think about it with this example here, what I drew here, right? We found our tangent line. We don't know b, but we want to find the approximation of b. Well, how do I do that? I'm just going to plug in the x value for b into my line, and then I can find the y value, right? And I can just find what the approximation would be. And this question is asking us to approximate f of 2.2, right? And it's an approximation. F of 2.2, it's like actually here, right? It's going to lie on the function, but we're just approximating it using a tangent line. So again, we're going to actually find the point here. So let's approximate it by plugging in 2.2, right? So it's going to be y minus 7 equals 12 times x minus 2. What that's really is going to be once we plug in 2.2 is y minus 7 times 12 times 2.2 minus 2. Now that's equal to 12 times 0.2, and that is equal to 2.4. I'll give like 10 seconds for people to catch up in case you're not caught up.
You don't move the -7 to the other side?
That's the final step. I haven't done that yet.
Oh.
But you're right. Yep, you're exactly right. So our final answer is going to be y equals 9.4. So I think that was really easy, but I mean, that's the gist of linear approximation. Basically, we weren't able to find what 2.2 is exactly, but using the tangent line to 2, we were able to approximate 2.2. So at x equals 2.2, f of x is approximately 9.4. So you can think about it in that way. Okay, so hopefully everyone has that copied down and understands that process. I'm actually going to skip down to a few practice problems. So I'm going to have everyone do number 2. Take probably 5 to 6 minutes to do problem number 2. And once you figure out, like, once you have the equation set up, I think like A and B will like B is not going to be double the time of A because you're just plugging in a new 2.7 instead of 3.1. So that should be pretty quick. And then I'm curious what everyone gets for part C, what your answer is for part C. So yeah, please start now. You have like 6 minutes or so. Once you have an answer for any of the parts, you can just chat me the answer, or if you like just want to contribute at all, just chat your name. But yeah, so once you complete the problem, please chat your name. So Daniel, I'm not sure if you were here because you just rejoined the call, but we're attempting problem 2 right now.
Nah, because my Wi-Fi just kicked me out. I just came.
Okay, yeah, no worries. We're trying problem 2, so we just started, so don't worry about that.
All right.
3 more minutes or so. Awesome. Thanks, Jamani. Thanks, Aaron. Thanks, Reese. Thanks, Kiana. Yeah, definitely seen a lot of good answers. Thanks for letting me know, Mercy. Thanks, Kayla. Okay, so I'm gonna start calling on people and then just kind of like walking through the problem. So actually Ansel first. So Ansel, for the first part, how did you start the problem?
Well, I just put it. I just decided to find the slope, so I took the derivative of x squared minus 4x.
Awesome. Yep, that's always a good first step. So really quickly. So sorry, what did you get for the derivative?
I got 2x minus 4.
Exactly right. And then what did you do after that?
And then from there, I plugged in 3 for the x.
Mm-hmm.
And after I simplified everything, I got m equals 2.
Yep, awesome. And then what did you do after that?
And then from there, I plugged 2 back into the original equation that we were given.
To find the point?
Yeah.
Okay. Yeah, you're definitely on the right track there, but I will caution, so 2 is our slope, right? That's our slope. If we want to plug in a point, we're going to plug in x equals 3, right?
Yeah.
So yeah, but yeah, that's definitely the right idea. So x squared minus 4x, we're going to plug in f of 3 is equal to, that's going to be 3 squared minus 4 times 3. Just writing this out really quick. So that's 9 minus 12 is equal to -3. So our point is going to be -3. Well, so it's equal to -3, and then our point is going to be 3 comma -3, right? Because this is the other half of our point. Okay, thanks, Ansel. Kayla, could you come off mute and then continue this on from here? So what's the equation of our actual line?
I said it's y plus 3.
Yep, awesome. So y plus 3, because it's y minus y1. So y minus -3, we're going to get a +3. Great. And then, sorry, go ahead.
Equals 2x, or 2 parentheses x minus 3.
Yep, awesome. So this is our equation. And then if we were to try to approximate 3.1, what would you do next?
substituted in for x.
Yep, exactly right. So basically we got our tangent line, right, to the curve, right? And we're trying to find, this is at 3, let's say, we're trying to find 3.1. Well, we don't know what if we don't know what the value actually is. So let's just plug it into our tangent line and then we get an approximation. So we're going to plug in 3.1. So y plus 3 is equal to 2 times 3.1 minus 3 is equal to, that's equal to 0.2, right? So y is equal to negative 2.8. Yeah. Oh, wow. I actually did this wrong in my notes. So I added. So yeah, I'm pretty sure the answer is y is equal to negative 2.8. So great job to anyone who did that. And then really quickly, I'm just gonna, since we only have 2 minutes, for part 2, we're gonna do, part B, we're gonna do the exact same thing where we plug in 2.7. And I think the answer for that is, I have this in my notes as y equals negative 3.6, but that might be wrong. But yeah, that's kind of besides the point. So we're going to get a certain value for part B. I'm going to put a question mark in case that's wrong. Let's see. So for part C, can I get Derek and Reese to come off of mute and then discuss part C? Or if you want to suggest an answer for part B also, that's totally fine. But
I had a question.
Yeah, go for it.
For part 1, cause
Oh, okay, yeah.
Cause well, you said 'cause I know when you multiply 3.1, it's supposed to be 6.2, right? And it's supposed to be 6.2.
Yeah.
Isn't that gonna be?
Yeah. So it's going to be 3.1 minus 3 first, right? Because you're doing the thing in the parentheses first.
Oh yeah.
So that's going to be 0.1, and then you multiply that by 2. So it's going to be 0.2.
Oh, you do all right. I thought we was doing distributive property.
You could do that actually. It'd be 2 times 3.1 is 6.2, and then minus 2 times 3, which should be 6. So it'd be 6.2 minus 6. So that'd also be 0.2. So that does also work. But yeah. Yeah, just don't forget to do this stuff in the parentheses first. I think that's what makes it easiest. And then, sorry, Derek, you want to come off mute?
I had a question about part A too.
Okay, yeah, go for it.
No, he asked it already. I had the same question as Reese.
Oh, okay, about the 2.
Yeah.
Yeah, so yeah, I'm sure you guys all remember like PEMDAS. So just do the parts in the parentheses first, then exponents, then multiplication. But yeah, so 3.1 minus 3 is 0.1 times 2. I know it's basically the end of class now, so does anyone have just like a really quick thought on part C, and then we can end class? You can raise your hand or chat your name. Mercy, go for it.
I think that the f3.1 will be more accurate because if you're doing it in like relation to f of 3, and 3.1 is closer to 3 than 2.7 is.
Yep. So that is kind of a key concept is we're in relation to x equals 3, right? So 3.1 is closer. So it's going to be more accurate, or generally that's the concept. 3.1 is going to be closer, so it's going to be more accurate compared to 2.7. And if we want to think about that, right, like if I draw a graph, right, and I'm doing tangent line approximation, and I draw this tangent line, right? If I'm approximating this point, okay, then that's pretty close, right? The point is pretty close, so I can kind of reasonably approximate that. If I'm approximating this point, like way over here, right, way far away, then this tangent line approximation is like, I mean, it's basically useless. Like, how good is this approximation going to be? I'm going to get a value over here. So yeah, so basically the value that is closer to the point that we're referencing, in this case, x equals 3, is going to be more valuable. So yeah, so that is it. Sorry for going over again. Besides that, just look out for the homework packet. Make sure you do turn in your class notes, exit ticket, etc. If anyone has any questions, feel feel free to stay after class. Yeah, thanks everyone for coming. Hey Derek, hey Kiana, you have any questions?